Today, what we're going to be looking at is data handling. So data handling is all of your means, your modes, your medians, and your range. So you'll be given a data set wherever the data set revolves around, and the data set could revolve around a whole bunch of things. So it could be the number of cars that pass a toll gate in an hour. Could be the number of calls into a call center. It could be a whole range of things. The number of shoppers in a shop per day. It could be the number of red cars that pass a certain robot or traffic light, if you're not South African, per hour or in a day. It totally varies. So we're going to be having a look at these 4 measures of data, how to work it out, what they actually are, and then we're also going to have a look at how are they influenced by some extreme values. All right, so data handling. So let's say we have the number of calls that come into a call center between a particular hour on consecutive days. So these are your data values. You have 14, you have 5, you have 8, you have 6, you have 12, you have 10, you have 4, 11, 3, and 6. First thing we got to do, let's count how many data values we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data values. Okay, great. That's an important aspect to remember. So we have 10 values. We're going to be looking at, as I said to you, the mean, the median, the mode, and the range. So when it comes to mean, median, and mode, these 3 values measure central tendency. Now, you may be asking yourself, what does central tendency mean? I mean, that sounds like a bit of a weird term. So central tendency is a nice fancy way of saying you're trying to measure where is the middle of your data set. But these 3 are different measures. They use different things to measure. So let us start out with my mean. So what is a mean? Well, a mean is the most commonly well-known one, which is average. So if you have a certain number of tests and you want to find your average mark, you are calculating the mean. How do you calculate the mean? You sum all the values and then divide by how many there are. Great. So I've given you another name for the mean. I've given you how to calculate it. I haven't really told you what the mean actually is yet. So what is the mean? The mean is a place in my data set where it's somewhere in the middle that if you calculate the distance between this mean value and any of the other values, any of the other data points, and you sum all of those together, they will cancel each other out to become 0. So that is the definition of the pure middle. All right. So what we're going to do is once we find the mean, that definition that I've just given you will make a little bit more sense. So let us calculate the mean. I'm going to use blue. Sometimes you'll find in books that mean has a symbol known as X bar. So the little line above is known as a bar. So this X could be a Y, it could be a Z, it could be anything. The bar is what makes it a mean. And the X then relates to the data set X. All right, so my mean is going to be the sum of all of these, 14 plus 5 plus 8 plus 6 plus 12 plus 10 plus 4 plus 11 plus 3 plus 6. All divided by how many there are, and we found out here there were 10. We can add all of these together and we get 79. And 79 divided by 10 is 7.9. So that means if I take 7.9 and I subtract it from each of these values, so 14 minus 7.9, 6.1. 5 minus 7.9, minus 2.9. 8 minus 7.9 is 0.1. 6 minus 7.9, minus 1.9. All the way to the end, 6 minus 7.9, minus 1.9. And you add all of those values together, you will find that the total comes to 0. So it literally is the exact middlemost point along this data set. Next thing we're moving on to is going to be our median. All right, so remember we had mean, we had median, and we have mode. So in answer to you, Yana, so I am still in Zoom, and I'm still using the whiteboard, but what I've done is I've just resized the whiteboard a little bit for me on the screen so that I can have the chat on the same screen instead of the screen next to it. So it's just a convenience thing for me. All right. So now that we have finished with our mean, we can change back to red, and we are going to be having a look at the median. What is my median? It is the middle data value. Now you might be saying, cool, that's nice. That's exactly the same thing. Well, no, the middle data value is irrespective of what the actual data values are. It's just relative position in the data set. All right, so if we're looking for a position in the data set, we need to very importantly hashtag order the data. All right, always order your data set. So when we order this data set, we end up with 3, 4, 5, 6, 6, 8, 10, 11, 12, 14. So just to be sure that we have got everything, 3, 4, 5, 6, 6, 8, 10, 11, 12, 14. It is very important you actually check this. And when you do this, you actually mark off the values, because that way you can actually get stuff to work properly. Someone says 9 is missing. There was no 9 to start with, to my knowledge. No, there was no 9 to start with. All right. So now we are literally going to be looking for the middle. And there are 2 ways of doing this. One, we can literally cross out as we go. So we cross out first and last, then the next 2 in, then the next 2 in, then the next 2 in. And we see that we have ended up in a scenario where we have 2 values in the middle. Is your median both values? No. So what you need to do is you need to now find a middle of these two values. And how do you find the middle of two values? You take an average, a mean, which we've just dealt with. And how do you calculate a mean? You add up the values, divide by 2. But luckily, you can literally do this just by inspection and say, what's the middle here? Great, it's going to be 7. If you weren't sure and you wanted to add them up, 6 plus 8 is 14, divided by 2 is 7. The other option that you have is realizing that we have 10 data values. And just to be totally clear, this is my median. That is the end of the answer. I'm not going to be giving you another method. So I can find the position by using the formula n plus 1 over 2. So n is the number of data values I have, which was 10. So 10 plus 1 over 2, which is 11 over 2, which is 5.5. Is this my median? No. This is my position of my median. So I want the 5.5 value when I've ordered my data sets. So I want first, second, third, fourth, fifth, and a half is halfway between this and the next one, which makes 7 as well. All right, so remember the mean 7.9. Here, the median is 7, different value. Let us have a look now at the mode. So here is the mode. What is the mode? The mode is the most commonly occurring number. So it is your most common. So which value appears the most often? Well, you could either do it from this version or you could do it from your ordered version again. So just that we have the ordered version again, 3, 4, 5, 6, 6, 8, 10, 11, 12, and 14. Now, which one appears more than once? Well, that's quite clear, actually. There we go. So these appear the most often, which means that my mode is 6. Done. No calculation involved, no nothing involved. So the mode, from what I've been told, actually comes from a French word, which means the most fashionable, which means that it should be the most common to see. All right, so very interesting. The mean was 7.9. The median was 7, and the mode is 6. So what is the middle of the data set? Well, in actual fact, that question is irrelevant. And not only is it irrelevant, it's a misnomer. So it doesn't have an answer because it depends what measure of the middle you are using. Through calculating all of these, you can also very easily see which ones are going to be influenced highly by extreme values. So the mean that takes into account every value that you deal with, that is definitely going to be influenced by extreme values. So if I take this data set and, for example, I add on 100, how is this going to influence my mean, my median, and my mode? Well, my mean is going to change because instead of being 79 divided by 10, it's now going to be 179 divided by 11. And that comes out at 16,27. Very different from only adding one value on. What happens if I have a look at my median? Well, my median, if I add on 100, means that I just have another value. Remember, median is irrespective of what the values are. Therefore, it is not going to be highly affected by extreme values. It's going to be affected, but it's literally just going to shift from being here to being the 8. Not highly influenced. What about my mode? How is my mode going to change with this extreme value that I've introduced? It's not going to have any influence at all, because this is not a number that has been in the set already. So therefore, it's just another one occurrence value. 6 occurs twice. And like for the 100, it just sits in the corner sulking. All right. So out of these, the mean is the only one that is going to be heavily influenced by my extreme values. So if ever you have data values that have been entered by hand, something like this 100 very possibly could actually just be a typo where the person typed 1 and 0, maybe held the 0 for too long, and it came up as a double 0. So it's literally resulting from human error and should have just been the value of 10. Later on in courses, when you come up to your IGCSE level, your international GCSE, then you will start dealing with outliers and errors like that. All right. Now, I said you were going to be dealing with 4 things: mean, median, mode, and range. So let us have a look at range. And pen. Range. What is range? Range is actually a measure of the spread of the data. So it is no longer a measure of the central tendency or the central bit of your data. It is now saying, all right, how far away from the middle is it actually calculating? So the range is a nice simple calculation. It is simply your max value minus your min value. Very nice, very simple. So if you have 20 values, but your range is only 3, that means that all the values are like this on your number line. But if your range is 100, you have values that are highly, highly spread out. All right. So let us have a look at this. We need to find our max and our min. So once again, I'm going to write out the ordered data set just so we can see this slightly more clearly. 10, 11, 12, and 14. All right. Therefore, this guy over here, here's my min. This guy over here, here's my max. And therefore, my range is 14 minus 3, which is 11. Great. Nice, easy calculation. So therefore, the spread of data values is 11 within the data set that we have. So because these numbers are quite low, that is quite a fair spread, because I mean the values are close to 0 and the max is only 14 and the spread is 11. So it's a fair range. What about if I include extreme values into this? What about if I add on 100? Well, if I add on 100, this is no longer the max. This is now the max. And therefore, my range will be 100 minus 3, which is 97. Far bigger range, which means highly influenced by extreme values. Very important. So when doing data handling, it is crucial that you know exactly how to calculate stuff. You know when to order and when not. Generally, it's a good idea to order because the only thing that doesn't really require ordering is your mean, but anything else, it's far easier to order it with. So remember, the two that are influenced highly by your extreme values are range and mean. Your two that are not is your median and your mode. So 4 different calculations, none of them direly complex, but all of them very necessary so that you can then actually get the marks and understand what you're doing.